In this video, we are going to learn how molar volumes of gases can be calculated from experimental data. There are two types of experimental data that can be used to do this, along with example calculations that can be applied to any other situation. In the first experiment, you can measure the mass of the gas and the volume it produces. From this reaction setup, you can measure the mass lost by the solid when it is heated. The mass lost by the solid in the test tube is the same as the mass of the gas produced. You can measure the volume of the gas produced by how much water is displaced from the flask into the beaker. How might you work out the volume for 1 gram of oxygen if you knew that 0.83 grams of oxygen produced 0.625 litres of oxygen from this type of experiment? Pause, calculate, and continue when ready. The answer is to divide 0.625 litres of oxygen produced by 0.83 grams. This means that 1 gram of oxygen gives you 0.753 litres of oxygen. Now you know the volume that 1 gram of oxygen produces, it's possible to calculate oxygen's molar volume. Remember, this is the volume of gas produced by 1 mole of a gas. The mass of 1 mole of oxygen molecules, O2, can be found using the periodic table. This is called the molar mass. If 1 mole of oxygen atoms have an atomic mass of 16 grams per mole, what's the mass of 1 mole of oxygen molecules? Pause and continue when ready. The answer is that a mole of oxygen molecules containing 2 moles of oxygen atoms, the molar mass for oxygen molecules would be 32 grams per mole. Finally, by multiplying the molar mass of oxygen by the volume of gas produced by 1 gram of oxygen molecules, you can calculate the experimental molar volume for oxygen gas. This you do by multiplying 32 grams per mole by 0.753 litres. The second way you can calculate an experimental molar gas volume is from density and molar mass data. The densities were measured at standard temperature and pressure and are quoted in grams per litre. There are some examples here. In order to calculate the molar gas volume using this data, you have to divide the molar mass by its density. Pause the video and do this for each example. When completed, restart the video and check your answers against those in the table. Did you get these molar gas volumes right? You have to remember, the molar gas volume of a gas at room temperature and pressure is approximately 24 litres per mole, whereas at standard temperature and pressure it is approximately 22.4 litres per mole. So you would expect your answer to match one of these values.